All right, so I'm going to kind of help you guys out at first. You see this 70,000? I want you guys to rewrite that 70,000. But use a 10. Like it's going to be something times 10 to a power. Okay, I can rewrite 70,000 or 70,000 as 7 times 10 to the fourth power. Now that's scientific notation right there, people. Normally we write it with an X, but I'm not doing that. Okay, so we can rewrite this though, because now we have multiplication inside of a log. Whenever we have multiplication inside of a log, what do we write it as? 2 logs now, but with addition. So log of 7 plus log of 10 to the fourth. And so now, do we know what log of 7 is? Look at the chart. Look at the chart. Log of 7 is 0.8451. And then what is log of 10 to the fourth power? Quattro. Now you'll love addition because we don't have to do like a lot of thinking. The decimal is right after the 4, so it would just be 4.0000, and you would add these. And you don't even need to set it up. You could just do it because it's so simple. We have 4.8451, and that's our answer. Now if you guys actually plug this into a calculator to check to see if you were right, you would get the same thing. Okay, but we're trying to use only the table, no calculator. Okay, so what about B?
Patey, you're going too fast.
How would you rewrite 0.0011? We can rewrite this 0.0011 by going 11 times 10 to the what power? Oops, I don't want to write the X, I want to do that. Times 10 to the negative 4. So this one's negative 4. Alright. Okay, so now we can split that up by going log of 11 plus log of 10 to the negative 4. Is everybody still with me? Yes. And then we get log of 11 from right here. Log of 11 is 1.0414. That's how they did in the old days. They used a table. They didn't have a calculator. Plus, what is log of 10 to the negative 4? Negative 4. All right. We have a negative and a positive number. We have to subtract them. You guys remember this? Okay, let me show you. I'll show you right now. We have 4.0000. 4 zeros. 1.0414. Subtract. Right up here, right way up here. Okay? So if I subtract those, let's see. I would borrow, because this is how you guys learned how to do it. Man, I had to borrow a lot right there. What is 10 minus 4? 6. 9 minus 1? 9 minus 4? Then we have 9.2, yeah? Yep. So we got negative 2.9586. So for the log of 20, we can rewrite that as log of 2. Guys, unnecessary, the extra talking. See, I got people explaining it over here, so I'm okay with that. That doesn't give you guys the okay to start talking. Alright, so we have 2 times 10. That'll give me 20. And I have a log of 2 right up here. And 10, I just know what log of 10 is. Log of 10 is like the easiest log. So I have log of 2 plus log of 10. We're just splitting it up. Log of 2 is 0.3010. And what's log of 10? 1. And so we have 1.3010.
Yeah. Okay.
The adding ones are way more simple than the subtracting ones. Now for this next one, don't let this decimal scare you. Just remember what you know about scientific notation. We want to get this decimal way over here. Well, it's a big marker. We want to get this decimal way over here in front of this 5 because when the decimal is there, you can ignore the decimal. You don't even have to know it's there. So we're going to rewrite that number as kind of like a scientific notation number. I mean, I'm using an X here instead of a dot. I hope that doesn't mess you up. So what would the power be for this 10 in order to make this 5 back into this number? it would be 1, 2, 3, 4, 5. It would be a negative 5 because we're moving backwards. We're moving to the left. And so when we multiply by 10 to the negative 5, you're actually dividing by 5 tens. And whenever you divide by 5, whenever you divide by 10, you're moving the decimal to the left. See, if I go 5 divided by 10, that's going to equal 0.5. Well, if I do this 5 times instead of just once, then it'll move the decimal all the way back to where it was to be. So I'm allowed to write this because it's exactly the same as that. So now I have a multiplication right there, and like before, we were just using dots, and so I'll use a dot here. And so because we have multiplication inside of a log, we're going to split up that log into 2 logs. Each number that's being multiplied gets his own log, and so this is going to equal log of 10 to the negative 5. And we know that log base 10 of 10 to any power is just going to be that power. So we have minus 5, and log of 5 we're going to get from our table, which is 0.6990. 0.6990, and because we got subtraction here going on, so let's review our subtraction here. We have a negative 5 and a positive 0.6990. The negative 5 is farther from 0, so that means our answer is going to be negative. Let's go ahead and do our subtraction action here. I'm going to make 5 have 4 zeros because I'm going to subtract from that 0.6990. Okay, I can subtract zeros, no problem. Can't subtract 9 from 0 in this method of subtracting. Let's see, we got to put a 4 right here, make that a 10. We're going to borrow from that, make that a 10, and borrow from that, make that a 10. So now I have 10 minus 9. That's going to give me 1. That's 0, that's 3, and then 4. So our answer is negative 4.3010.